Hello everyone. In this video we are going to be looking at function operations, multiplication, and we'll call this part 1 because I'll do 2 videos for multiplication. In this video we will see again that we are given 2 functions. In this case these are new functions compared to the first 2 videos. We have f of x, which is 6x minus 5, and g of x, which is negative 3x plus 8. Now we're going to be doing multiplication. You can see multiplication a few different ways. I have given you 4 examples down below. Here, kind of color-coded, green would be the ideal way that you may see them or write them. F times g of x or f of x times g of x. And in this case, we use the closed circle for multiplication. Open circle would be a different function or operation called composition, which we'll be seeing in a later video. Now, over to the right, we can see the orange one is next. In this case, this might be something you see a little more common where they just eliminate the closed circle in between. I would prefer that you have the closed circle there, but that's something you may also run into. And then the last one, instead of using a closed circle, they used an x for multiplication, which I would suggest avoiding because it gets real confusing if you're talking about a variable x or a multiplication symbol that looks like an x. So in this case, we're going to focus on the 2 green examples, which would be where you should probably think about and write your problems that way. So let's take a look at how we multiply. Just like with the adding and subtracting, what I like to do is write the 2 functions down in the order that they show up. In this case, f times g of x, so I'll write f of x first, which is 6x minus 5, and I'll put that in parentheses, and g of x, which is negative 3x plus 8, which will also go in a set of parentheses. Now, when it came to addition and subtraction, we would put either a plus or minus sign in between the 2 sets of parentheses, but with multiplication, we wouldn't put anything there. So that's something to kind of keep a lookout for. Common mistakes I've seen in the past, people get confused between adding, subtracting, multiplying, when to do which ones. So just be careful. Multiplying is when there is nothing between the 2 sets of parentheses with the functions. Now, in order to multiply these 2 together, we are going to use distributive multiplication. So essentially what that translates to is everything or every term from one function in one set of parentheses gets multiplied by every term in the other function or the other set of parentheses. So what I like to do is take a look at the first function, whatever one shows up on the left is my preference, which is 6x minus 5. And I want to take a look at the first term. The first term in this function is going to be 6x. And what I'm going to do is I'm going to take 6x and I'm going to multiply it by all the terms in the other function, g of x. So 6x is going to get multiplied by the first term, which is negative 3x. And I'm going to multiply those 2 together. And when you're multiplying these, what I like to do is treat it as, 2 different steps. First, I multiply the coefficients together, which would happen normally. Negative 3 times 6 is negative 18. But then we also have the variables. And the way that we multiply variables together is we use the laws of exponents and add the exponents together. In this case, we don't really see an exponent on the x, which should lead us to know that default would be that there's a 1 exponent on both those x's, right? So just pretend there's a little 1 on both of those. So when we add those 2 exponents together, we get 1 plus 1, which is 2. So it's going to be 18x squared. Okay? And then what I'm going to do is I'm going to look. The 6x was multiplied by the first term in the function g, so is there any other terms I have to multiply? And yes, there is. I also need to multiply it by the constant of 8. So I'm going to multiply 6x times 8. Now in this case, there is no variable in the 8, so I'm just going to multiply the 6, the coefficient in the first term, times the 8, which is going to give me 48. And then since there was an x in the term in the function f, I'm going to keep that x, but since there's no other x's to combine it with, the exponent will stay as 1. Okay? Now we're going to look back at that first function. I've taken the 6x from the first function and multiplied it by every term in the second function. So it's time to move on to the second term in the first function, which is negative 5, and multiply that by all the terms in the second function. So I'm going to multiply negative 5 times a negative 3x. In this case, a negative times a negative is going to give us a positive. And multiplying the coefficients, negative 5 times negative 3 is a positive 15. And since the negative 3 has an x, it's going to stay and go to a plus 15x. And then the negative 5 also gets multiplied by the positive 8, which gives us negative 40. Okay? Now we're done with the multiplying part of the operation on the functions here. But what we're going to also need to do is then combine like terms. And this kind of gets treated the same way that we did the addition problem, or even similar to the subtraction. We're going to combine the like terms. So in this case, I'm going to go through x squared. There's only one, so that's the 18x squared. But then for the x terms, there's two of those. So I'm going to have to combine those two together, and that's going to give me 48 plus 15, which is 63x. And then there's only one constant term, which is negative 40. So I'm going to now be finished combining those two middle terms that join together to become that 63x. All right, and we'll write this as f times g